Alright, we're going to do a little experiment here with a piece of dry ice that we got in an Omaha Steaks container. Alright, as you can see, typical behavior of frozen CO2, melting at room temperature, sublimating. Dip it in water, and it expels the gases very quickly. But because CO2 is a non-polarized molecule, unlike H2O, if you put dry ice in a microwave, in theory, it shouldn't have any effect, because it can't turn the molecules, vibrating them quickly like it does with water. So, if we stick it in there, 3-0, start, 30 seconds on, and we watch it turn in there. As you can see, it doesn't appear to be sublimating any faster than it was at room temperature. There's no gases escaping out the bottom of the microwave. It's just turning, barely even seems to be affected. Sure enough, after 30 seconds, open her up. Container isn't hot. It's still melting, sublimating at basically the same rate as it was beforehand. Now, just to see what this would look like, Steve, can I get that water? If we were to just add a little bit of water.
You can already see it's melting much faster.
Yeah, you can see it's sublimating much more quickly as it was before.
That's relatively cold water.
Yeah, and just sticking it in the microwave, you can see that if it had sublimated more quickly, the microwave would have been much more filled with gas, with CO2. But because the molecules were unaffected by the microwaves, it didn't sublimate any more quickly. That's science.